scientific revolution began in Europe towards the end of the Renaissance era and continued through the late 18th century, a period known as the Enlightenment. During the scientific revolution, experimentation and observation were used to replace the traditional faith and belief system. This resulted in the creation of the scientific method that is still used today. It consists of first observing a problem and stating a hypothesis, which is an educated guess, and which will be tested during the experimentation. During the experimentation, scientists collect data and determine if the hypothesis was correct. Scientists then share their data with other scientists to compare results. In this case, they would publish their ideas in pamphlets or books. The scientific revolution in the 16th and 17th century was an era in which new ideas and knowledge in physics, chemistry, astronomy, biology, and medicine transformed medieval and ancient views on nature and laid the foundations for modern science. The scientific revolution was a need by sailors due to the navigational problems they faced in the overseas expansion. New instruments that would result because of their need would be a telescope, barometer, thermometer, pendulum clock, and a microscope. The scientific revolution, like the Reformation, was another challenge to the Catholic Church, and they would not take it quietly. Power was more than truth. In 1543, Andreas Vesalius published his book, The Structure of the Human Body, in which renewed and modernized the study of anatomy. He was a Flemish physician and anatomist who dissected bodies and hired artists to draw what they observed during his dissection. Because of this, he is often referred to as the founder of modern human anatomy. He also analyzed the brain and named several parts, such as the thalamus and the corpus callosum. He also believed that the skeletal system was the framework of the human body. One of his greatest contributions to science was the discovery of the heart's function and the circulatory system. He studied the heart and named several chambers such as the right atrium, left atrium, inferior and superior vena cava, which are still used in modern science. How cool is that? Do you want to hear a fun fact? Well, Vesalius finished The Structure of the Human Body in 1543 and sent a copy to King Charles V. In it contained 200 hand-colored illustrations that were amazing, since very little was known about the human body at the time. The king was so impressed, he invited Vesalius to be one of his own personal doctors. What sparked the scientific revolution was Copernicus' challenge of Ptolemy's geocentric theory. Born in 1473, he was a Renaissance astronomer, and in 1543 he proposed the heliocentric theory in his book On the Revolutions of Heavenly Spheres. The heliocentric theory argued that the sun, not the earth, was at the center of the universe. This was hard to believe by many because not only did it challenge Ptolemy's geocentric theory from 2nd century AD, but also the Bible's book of Genesis. Copernicus didn't publish his book until shortly before his death in 1543 due to his fear of the Catholic Church and the community, although he did dedicate his book to Pope Paul III. Some of his famous responses to the heliocentric theory were made by both Martin Luther and John Calvin, who condemned his ideas. Just to give you a perspective of what it was like to live during Copernicus' time period, we will let Professor Harry explain.
Thanks, Diana. Good morning, students. As you can see, the Earth is in the middle of our solar system. All the other planets revolve us. Don't you agree? No? I don't feel the Earth moving at all, so how could Copernicus possibly be right? But the geocentric theory is obviously right.
Copernicus died on May 24, 1543. Legend has it that the first printed copy of De Revolutionibus was placed in his hands on the very day that he died, allowing him to take farewell of his life's work. Galileo helped prove the heliocentric theory with the help of the telescope in which he created himself. Here's a video about Galileo's invention of the telescope.
Into a useful device.
Hearing reports of a new invention from a lens maker in Holland, I determined to fashion a device for myself and was able to make considerable improvements in it.
Galileo realized that spectacle makers could not give him the lenses that he needed in order to make this device more powerful. That is extremely difficult, and it certainly was in 1610.
At first, Galileo was only interested in the optics of the telescope. With his improved lenses, he increased its power tenfold. But his lenses did more than magnify. By reshaping these pieces of glass, Galileo would eventually reshape our view of the world. With his telescope, Galileo first set out to make some money. The naval arsenal of Venice was the greatest in all of Europe. What if the arsenal had a way to spot enemy ships hours before they appeared in the harbor? Wouldn't this give the Navy a distinct advantage? Installing his new device at the top of St. Mark's Tower, Galileo arranged persuasive, real-life demonstrations.
In 1591, on the Leaning Tower of Pisa, Galileo demonstrated gravity by showing that a 1-pound weight and a 100-pound weight would hit the ground at the same time. In 1616, the Catholic Church declared Copernicus' theory to be heretical. In 1633, the Roman Inquisition forced Galileo to take back his ideas in support for the heliocentric theory. He was placed under house arrest for the remainder of his life. Francis Bacon is well known for his inductive method, which was used in scientific experimentations. This was composed of an observation, forming a hypothesis, conducting experiments, and then organizing data. In 1620, Francis Bacon publishes Novum Organum. He tries to get the scientific communities together by explaining how they are similar and go hand in hand. Together, Bacon and René Descartes' deductive reasoning would form the scientific method. As I have just mentioned, his deductive reasoning by René Descartes in 1637 was based on logic, which led to facts. In that same year, he developed geometry. Brahe was the leading astronomer in the 16th century who built a laboratory that helped him collect data about his observations of the universe. His laboratories were sponsored by several nobles, but the last one he built before his death was sponsored by Rudolf II, a Holy Roman Emperor. He didn't believe in the Copernican theory, but his data would later on prove it. His data remained important for several centuries because Brahe's laboratory was by far the best in Europe at the time. Johann Kepler was born in 1571. He was Brahe's assistant who used his data to mathematically prove the Copernican theory. He also developed the 3 laws of planetary motion. They stated, orbits of planets are elliptical. Planets do not move at uniform speed while in their orbit. The time it takes for a planet to orbit the sun is directly based on the distance from the sun. In 1643, Torricelli invents the barometer, which is used to measure air pressure. This was a large step in the understanding of the properties of air. We still use the same basic structure for the barometer today. In response, the unit of pressure called torr is named after him. Bruno, an Italian monk, laid out his philosophies that the universe was an infinite size and that the Earth, Sun, and planets were all moving constantly within it, and that there was no means located at the center. Then proclaimed as a heretic and burned at the stake. In 1614, John Napier publishes Description of the Marvelous Canon of Logarithms. Napier invented and charted logarithms, which was an important invention because it would later on help solve difficult math problems in science. In 1656, Otto von Guericke invents the air pump, but used vacuums to perform his first experiments. In the process, he demonstrated many of the properties of gases. Viet invents analytical trigonometry, which was essential to the study of physics and astronomy. Sir Isaac Newton incorporated Copernicus and Kepler's astronomy with the physics of Galileo into his own theory explaining order in the design of the universe. In 1687, Isaac Newton publishes Philosophia Naturalis Principia Mathematica. In his book, he talks about the principle of universal gravitation, in which everybody in the universe attracts every other body in the universe, as he describes it in a mathematical relationship. In the 17th century, Isaac Newton invents calculus, but also Gottfried Leibniz is also credited for inventing it also. William Harvey, through dissection, was the first to demonstrate that the circulation of blood through the human body is continuous, rather than consisting of different types circulating through the veins and arteries, as had been previously assumed by the ancient Greek physician. And that, folks, was the scientific revolution of the 16th and 17th century.